Welcome to the fourth part of the fourth module in CFF. Students, we have been dealing with Fanno flow in the previous sessions. Now we will move to some numerical problems based on Fanno flow. Okay. So first problem, dry air is traveling in an insulated constant area duct of 60 mm dia. So we have a duct here. So it is insulated means there is no heat transfer. It will be purely adiabatic. Okay, so constant area duct, so there is no area variation, so it is not isentropic, it is not adiabatic, it is adiabatic but not isentropic. Okay, the flow Mach number, the dia is given. Okay, dia is 60 mm. The flow Mach number at the entry here is how much? This is entry section. Mach number here is given as m1 equal to 2.5. m1 is given as 2.5. What is the maximum possible length to the pipe to achieve smooth flow without discontinuity if the average friction factor for the flow in the duct is 0.003? So it means maximum possible length of pipe to achieve smooth flow without discontinuity means at the exit the maximum possible for a Fanno flow, the maximum possible length for the duct corresponds to the length of the pipe required to choke the flow. So choking. So maximum possible length of pipe to choke the flow is nothing but the section where m will become 1. You know, right? Choking will happen when m becomes 1. Okay, so the exit Mach number is 1. So from Fanno, so this length will be L max. L max will be the length from entry point to the point where flow chokes. Okay, so this length should be found out. Okay, so how to find out? So dia is given, entry Mach number is given, and friction factor F is also given 0.003. Right here, F is given. Okay. So students, this is the Fanno table. Fanno table corresponding to gamma equal to 1.4. So since our fluid is air, gamma will be 1.4, corresponding to 1.4. If inlet Mach number is 2.5, you can see a particular term called F, 4F dash L max by D. So this is the pressure drop value. This is the pressure drop value. So corresponding to 0.25, pressure drop value is 0.432. So maximum possible length can be, so FL max 4F bar L max by D is equal to, corresponding to Mach equal to 2.5 is how much? 0.43, around 432, right? Around 432. Okay, so students, actually the F bar, this is mean. Okay, this is friction, average friction factor, so it will be F bar. So F bar is given, dia is given, the value is known, so naturally we can find out L max, right? L max can be found out. So 4 into 0.003, right? 0.003 into L max by D is how much? 60 mm means 0.06 meter, right? 0.06 meter equal to 0.432. So you will get L max corresponding to inlet Mach number. L max corresponding to the inlet Mach number, Mach 2.5. If the inlet Mach number is 2.5, then L max will be how much? 0.432 into 0.06 by 4 into 0.003, and that value will be around 2.16 meter. So maximum possible length for this particular situation will be 2.16 meter. So this L max will be 2.16 meter. So this is how to find maximum possible length if the inlet Mach number is given. Okay. So students, we can move to second problem. The average friction factor for a 50 dia pipe is 0.004. So we have a pipe here. Average friction factor F bar is given 0.5, 50 meter means 0.05 meter. Okay. And diameter is given 0.004, right? 0.004 meter. It will be meter. Okay, this is meter. Take it as meter. The Mach number of air at a particular section is in the pipe is 0.25. So I will take a particular section 1 here where Mach number is M1 is 0.25. Okay. So determine the length of the pipe if the flow ends at a Mach number of 0.49. So flow ends here at a particular Mach number. M2 is equal to how much? 0.49. Okay, this much parameters are given. M1 is given, M2 is given, F bar mean average, mean friction factor is given, dia of the pipe is given. Okay. So students, what should be found out? We have to find M1 is given as 0.25, M2 is given as 0.49, dia D. Okay. Diameter D is given as 0.0. Okay, wait. It's wrong. The friction factor is 0.004. Friction factor has got no unit. I'm sorry. I took it as meter, right? Sorry. Actually, it has got no unit. Friction diameter is 50 mm, means 0.05 meter, right? 0.05 meter. So here it will be 0.05 meter. F bar is 0.004. Now we have to find. So from students, from graph you can see that 4F bar L max by D corresponding to Mach 1 equal to 0.25 will be, okay, so look at the graph, point corresponding to 0.25 means in between this value, right? In between 9.37 and 7.687. So it will be around 8.5. Take it as 8.5. Okay, 8.537. So students, from this equation you will get 4 into, so this will be L max 1. Okay, L max 1, because this is for M1. This is for M1. For each Mach number, the L max varies, right? So here we have got 2 Mach numbers because we have 2 sections. So corresponding to this, you have to put it as L max 1. Students, L max 1 can be calculated as L max 1 is 8.5 into 0.05 divided by 4 into 0.004, right? So that will be around 26.678 meter. Okay. So students, what is the physical meaning of this particular statement? What is the physical meaning? So you have a particular Mach number for a particular section. From the maximum possible length for this, with this Mach number is some. This will be L max 1. L max 1. Where the flow chokes. So here flow chokes. So this will be M star, or M equal to 1. Here M equal to 1. Here M equal to 1. So this is an imaginary section. There is no such section. But there is the flow ends here at M2. M2 equal to 0.49. Right? 0.49. So for this M2 also, flow should end here. Flow should end at a section where M becomes 1. So even though it is an imaginary section, you can calculate this Lmax 2 also. So this Lmax 2 should be like this, because both should end at m equal to 1 only, right? So Lmax 2 can be found out how? So for f bar Lmax 2 by d at m2 equal to 0.49 should be, what should be the value corresponding to 0.49? You can see here around 1.15 in between this value, 1.15. So again you can calculate Lmax 2 as 1.15 into 0.05 by 4 into 0.004. It will be around 3.616 meter. So this will be 3.616 meter. So students, what will be this particular length? 3.616 meter. This will be Lmax 1 will be 26.6 meter, right? So our question is determine the length of the pipe. So the length of the pipe will be this one. Length L will be Lmax 1 minus Lmax 2, right? Lmax 1 by Lmax 2. L will be Lmax 1 minus Lmax 2. It will be 26.67 minus 3.616 equal to 23.06 this much meter. This will be the length of the pipe if the flow is Fanno. Okay, this is how we find length of the pipe. If the Mach number of two sections are given, find maximum possible length corresponding to both the Mach number, and the difference will be the length of the pipe. Okay. So third question. So we have air entering a circular duct of 15 centimeter dia with a Mach number 0.5. Okay. So we have a duct with 15 centimeter dia. Entry Mach number is 0.5. Pressure, static pressure at that inlet is 300 kilonewton per meter square. Temperature is 320 Kelvin. Average friction factor is given 0.005. Assume adiabatic flow with adiabatic choked flow. So choked flow means final Mach number will be 1. Adiabatic flow with friction. Determine length of the duct. Change in entropy. Change in impulse function. Loss in isentropic stagnation. So students, given dia equal to 0.015 meter, 15 centimeter, right? So it will be 0.15 meter. 115 meter. Mach number 1 is given 0.5. P1 static pressure is 300 kilonewton per meter square, means 300 into 10 raised to 3, that is 3 into 10 raised to 5 Newton per meter square, and temperature is 320 Kelvin, right? 320 Kelvin. And also friction factor, average friction factor F bar is also given as 0.0005. So what should be found out? Length of the duct should be found out. Since M2 is 1, length of the duct is maximum length, Lmax. So students, corresponding to, so for F bar Lmax corresponding to by D corresponding to M equal to M1 equal to 0.5 will be corresponding to 0.5, we will get it as 1.069. So Lmax will be 1.069 into D, dia is 0.15 meter, by 4 into F bar is 0.005, and the value will be 8.02 meter. So maximum possible length will be the length of the duct. So L of the length will be Lmax only. L of the length is obtained. Now we have to find change in entropy and change in impulse function. So first we can calculate change in impulse function. So change in impulse function is nothing but, what is impulse function? F1 corresponding to first section, F1 will be P1 into A into 1 plus gamma M1 square, right? So this equation you know. So what should be found out? F1 minus F2, right? F1 minus F2. But students, second section is nothing but choked condition. So choked condition will be F1 minus F star. So because second section Mach number is 1, so F1 minus F star. So F1 minus F star can be written as F1 into 1 minus F star by F, right? F star by F, F1. So corresponding to Mach number 0.5. Okay. So this will be with respect to point M1 corresponding to 0.5. The F star by F1. So students, have a look at here. You can see that F by F star is available. So corresponding to 0.5, F by F star is F by F star corresponding to 0.5 is 1.203, right? So here it is F star by F1. So F1 into 1 minus 1 by reciprocal, right? 1 by 1.207 should be found. So you should know F1. So how to find F1? F1 is this equation. F1 can be written as P1 into A. P1 is 3 into 10 raised to 5. A is pi by 4 into 0.15 square, pi by 4 d square for section area, plus 1 by 1 plus 1 point, gamma 1.4, Mach number 1 is 0.5 square. Its value will be 71567.94 Newton. So F1 is obtained. So F1 minus F2 can be written as F1 into 1 minus 1 by. So F1 minus F2, F1 minus F star can be written as F1 into 1 minus 1.203, right? So it will be 71567 into 1 minus 1 by 2.03, and the value will be 1207.7 Newton. So this is the change in impulse function for this particular case. Now we have to calculate loss in isentropic stagnation pressure. Loss in isentropic stagnation pressure. Students, you know the what the diagram. So since this is Mach number with the 0.5, so it will be on the upper side, right? Upper side. So this is 1, this is star, choked condition, star. So here M1 equal to 0.5, here M2 is equal to 1, right? So the stagnation pressure is here. The stagnation pressure will be this one, P01. P01, and the stagnation pressure corresponding to this will be P0 star. So naturally this stagnation pressure is lower than P01. So P01 is greater than P0 star. So there is a loss in stagnation pressure, right? So if you look at the table, Fanno table, you can see here that there is a column for P0 by P0 star. So if you know the corresponding P0 corresponding to 0.5, P0 by P star is 1.340. So corresponding to P01 by P0 star is nothing but P0 by P0 star corresponding to M1 equal to 0.5. That value is given given in the table as 1.34. But students, what should be found out? The loss in Actually P01 minus P0 star should be the value that should be calculated, but we don't know P0 and we don't know P0 star, right? Both the P0 and P0. So P01, this equation can be written as P01 minus P0 star as P01 out of the bracket 1 minus P0 star by P01, right? P0 star by P01. So you should know both P0 star and P01, or instead of P01 you can write it as P0 star by P0 at Mach number equal to 0.5, right? And this value, you know, P0 star by P0 at Mach number equal to, it will be inverse of 1.34. So P01 minus P0 star can be written as P01 into 1 minus 1 by 1.34, right? So P01 is still unknown. So P01 is the stagnation pressure corresponding to P1. Stagnation pressure corresponding to P1. So if this is P1, here this is P1, this is P01, corresponding to this P01, corresponding to this P1. But this process is, if you know the relationship between stagnation pressure and static pressure, you can easily calculate, right? So easily calculate. So since this particular process is isentropic process, you should take the isentropic table. So from isentropic table, for m equal to 0.5 and gamma 1.4, the corresponding isentropic table for gamma 1.4 and m equal to 0.5, we will get P0 P1 by P01 corresponding to m1 equal to 0.5 as 0.843. So students should note that this value is taken from isentropic table, because this particular process is isentropic process. The stagnation is taking place in isentropic, is corresponding to isentropic table. So from isentropic table you got this value, but you know the P1 value. What is P1? P1 is 300. So 300 by P01 is equal to 0.843. So P01 will be 300 by 0.843, and that will be around 356 kilonewton per meter square, right? Kilonewton per meter square. So 300 is taken as kilonewton per meter square. So if you know the P01 substitute here. You substitute here. So P01 minus P0 star will be equal to how much? 355 into 1 minus 1 by 0.1 by 1.34, and that will be around some 265.57, around this value, kilonewton per meter square. This will be the loss in stagnation pressure. Sorry, not this one. Around 90.3, the value will be 90.3 kilonewton per meter square. Okay, 90.3. So P01 is known. So P0 star is nothing but 90.3 plus P01 will be 90.3. Sorry, 90 P0 star will be P01 minus 90.3, and that will be 355 minus 90.3, and it will be around 265. So this is the value of P0 star. So the term you should find out is nothing but loss in stagnation. So this is loss in stagnation. Loss in stagnation. Now you have to find out change in entropy. So the question asked here is to find change in entropy also. Change in entropy here means should find S2 minus S1. So S2 here is S star only because flow is stopped at the end. S star minus S1 is equal to, you know the equation, R log P0 by P0 star. You should know the equation of entropy, and P0 by P star is R is 287, natural log by P0 is 355. Okay, 355. What was the value? 355, right? Okay, 356 or 35, around 356. This is 356. Put it as 356 by 265.5, and this value will be 84 joule per kilogram Kelvin. So this is how you find S star minus S1. Okay. So this equation we have learned in the previous class while studying the relations for perfect gas, Fanno relations for perfect gas. Okay, so you should know that equation for entropy, because entropy table is not available. So that's it. So we will move to another one more problem. So students, another problem, the average friction factor of a 25 mm diameter 12 meter long pipe is 0.04. So 0.004 is the average friction factor. Dia is 25 mm means 0.025 meter. Length is 12 meter. The condition of air at entry is M1. Okay, M1 is not given. Pressure 1. Static pressure is 2 bar. That is 2 into 10 to 5 Newton per meter square. And T1, static temperature is 300 Kelvin. Okay, 300 Kelvin. Determine the mass flow rate, pressure, temperature, and the Mach number at the exit. If the Mach number is at inlet is 0.25. So M1 is 0.25. So initially we have to find that M dot, mass flow rate. Mass flow rate equation you know, rho1 A constant area, right? So rho1 A into V1. So rho1 is nothing but P1 by RT1 into area is pi by 4 d square into velocity is Mach number into acoustic velocity, that is gamma RT1. Okay, so P1 is given 2 into 10 raised to 5 by 287 into 300 Kelvin into pi by 4 d square is 0.025 whole square. The Mach number 1 is 0.25, gamma is 1.4, 287 into 300. So solving this equation you will get m dot is equal to 0.0989 kilogram per second. The unit will be in SI only, that is kilogram per second, because we have changed all the unit into, because we have taken pressure in Newton per meter square. This is joule per kilogram Kelvin, 300 in Kelvin, this is meter. Okay, this is also in SI unit. So m dot will be in kilogram per second. So given length of the pipe as 12 meter, right? So students, M2 is unknown. So if you need to find P2, T2 and M2 are the things to be found out. So if you know M2, you can easily get P2 and T2 from the table. So you have to find M2. M2 can be find out using the technique that if this is the duct, this is the section 1, M1 equal to 0.25, right? 0.25. So you can calculate an Lmax 1, right? So length of the duct is this much only. So you can calculate Lmax 1. So how to calculate Lmax 1? So So if this is a section, Lmax 1 will be corresponding to third section, where section will be starred section, that is m equal to 1 here. So corresponding the second section you can also calculate Lmax 2, right? Lmax 2 also can be. So L is given, you can calculate Lmax 1. How? For f bar Lmax 1 by for fl by d will be nothing but 4f bar Lmax corresponding to m1. Lmax 1 will be Lmax corresponding to m1, that is 0.25, and that value is nothing but corresponding to L1, that is 0.25, right? 0.25 corresponding to 0.525, it will be around 8 point, it will be 8.537. Okay, so if Lmax 1 will be d into 4, it will be around 8.53. It will be 8.53 into d. D is 0.025 by how much? 4 into f bar. F bar is 0.004. So this will be Lmax 1. Okay, and the Lmax 1. Now we calculate Lmax 1. So students, but L is given. L is equal to how much? 12 meter. So for f dash L by d you can calculate, right? For f bar L by d you can calculate how much? 4 into f bar L, 4 into 0.004 into L 12 by d, how much? 0.025. We calculate this value, you will get 7.68. So students, you check this value for f dash L by d as 7.68 in your table. So corresponding to 4f Lmax by d, where this 7.68 comes. 7.68 comes for a particular Mach number. Okay, here it is 7.68. So 7.68 will be corresponding to m2, and that m2 will be okay, not like that, you have to write like this. So I will write an equation now. So students, for you know that Lmax, from this particular figure you can see that Lmax 1 minus Lmax 2 is L, right? So you can write like this, L equal to Lmax 1 minus Lmax 2, right? So Lmax 1 can, so if you add 4f bar L by d here, you can add here also, because 4f bar by d is common, 4f bar by d. So this is an equation. So 4fl by d you already got it as 7.68, and 4f bar Lmax 1 by d is how much? 8.53 minus this value you don't know. This value you can, 4f bar Lmax 2 by d can be found out from this equation. So 4f bar Lmax by Lmax 2 by d is nothing but 8.537 minus 7.68. So that will be around 0.857. So students, corresponding to 0.857, Lmax 2 will be corresponding to m equal to m2. So you check for this particular value what will be the Mach number from this particular table, corresponding to 0.857. So check here, where actually for what Mach number 4FL max by D becomes 0.857. So you can see that here between these two value, between that will be corresponding to M2 equal to 0.53. You can see that for F bar L max D will become around 0.857, right? So you will get, so if you backtrack this equation, you will get M2 as 0.53. So M2 is obtained at 0.53. So second section is obtained. So this section M2 equal to 0.53. Now you can calculate P2 and T2. How? Because P2 in the table here P by P star is available. So if P by P star is available, okay, P by P star correspond P2 by P1 can be written as P2 by P star by P1 by P star, right? So P2 by P star is nothing but P by P star corresponding to M2 by P by P star corresponding to M1. So P by P star corresponding to M2 means M2 is 0.53, M1 is 0.25. So 0.25. So from the table, corresponding to 0.53, P by P star is P by P star corresponding to 0.53 is around, you take it as some 2.01, take it as 2.01. Similarly, P by P star corresponding to 0.25, corresponding to 0.25 means somewhere here, that will be around 4.36. So substitute those values here. Substituting, you will get 2.012 by 4.361, and that will be around 0.461. So P2 by P1 is 0.461. So P2 will be P1 into 0.461. That P1 is already given as how much? 2 bar. 2 bar means 2 into 10 raised to 5 into 0.461. That will be 2 bar. That will be 0.92 into 10 raised to 5 or 0.92 bar. 0.92 bar. Okay. So the Mach number at the second section is 0.92 bar. Now similarly you have to find out T2 by T1. So T2 by T1 can be written as T2 by T star divided by T1 by T star, or T by T star corresponding to Mach 2 equal to 0.53 by T by T star into that Mach 1 is equal to 0.25, and from the table you will obtain it as 1.136 by 1.185, and it will be 0.959 from table. So T2 equal to T1 into 0.959, and T1 is 300 into 0.959 will be some 287.7 Kelvin. So this is how you solve different problems related to Fanno flow. Okay. So hope you have understood the solving method, right? So you can try to solve many different problems from textbook, and I will give you some problems as assignment also. So try to do those things. Okay. So I will wind up this session. Thank you.